Alright, we are looking at 2.7, which is proving segment relationships. So we're going to write proofs involving segment addition and congruence here. So we have a few postulates to begin with. Here we have the segment addition postulate, which is saying if I have A, B, and C, that AB plus BC equals the whole thing. So piece plus piece equals the whole segment. Reflexive property of congruence is just saying any two things are equal to each other, congruent to each other. Same thing with symmetric. AB is congruent to CD, then CD is congruent to AB, and transitive works that way as well. So, two-column proof here, saying prove that AB is congruent to CD, that if, that, then this. So, this is what they're giving us here, so that's the given. So we have AB is congruent to CD. Let me put my statements and reasons up here. Okay. Then after that, I'm going to say that in here, BC is equal to itself. So I have BC is congruent to BC, and that's reflexive. Reflexive property of congruence. Okay, now looking at this, I'm going to use the fact that AB plus BC equals AC. That's an A. And that is our segment addition postulate. I can also say the other side of that, where I have CD and BC is equal to BD there. So BC plus CD. So that's also the segment addition postulate. Okay, now I'm going to do some substitution here. So since we said at the beginning that AB was congruent to CD, I could replace this AB with a CD here. So I'm going to do CD plus BC equals AC, and that's substitution. So now I have this is the same as this. So we have this piece equals this, and this piece equals that. So that means that AC must be congruent to BD. So this is like if A equals B and, sorry, if A equals B and B equals C, then A equals C. So that is our transitive property. So this is going to be now BD is congruent to AC, transitive property of congruence. So when you're looking at proofs, you're trying to figure out ways you can substitute things in, exchange things to kind of get where you're trying to get with what it's asking you to prove at the end there. Separate these a little bit. Okay, one more proof here to do together. So we have our given, and then we have what it wants us to prove. So we are given that WY and YZ are equal to each other, so that would mean that they're congruent. We have YZ is congruent to XZ, which is over here. And XZ is congruent to WX. And we want to prove that WX is congruent to WY. So first, statements and reasons. Then we have our given, So all that's given. So now I'm going to use my definition of congruent segments to tell us that if that says those are equal, then I can say that those lengths are congruent to each other. Okay, so now what we're working towards is saying that WY is congruent to WX. So this is what we're working toward. So the next thing I'm going to say is, looking at what we have up here, this is kind of like if A equals B and B equals C, then I can say that A equals C. So I'm going to say that YZ is congruent to WX, which would be our transitive property again. Transitive property of congruence. And then we are really close to what we want to prove here. We want WX and WY, but we know that I can exchange this YZ is equal to WY here or here. So I'm going to substitute that in and say WY is congruent to WX by substitution, and that has gotten us to where we want to be then. Okay, so you have the one to try on your own here. This is fill in the blank, so you should be able to come up with some, look at some properties and whatnot, and see what you can substitute in there, things that we have used. And for your joke of the day, what do you call it when you rent some fake teeth? It's a dental rental. All right, I hope you have a great day, and make sure you're kind to someone today.